As we saw in the last video in our notes before, we have this nice useful trig limit for us. If we look at example 14, this fits our format for sine, so the limit is 1. This one fits the format for cosine, limit is 0. This fits sine, so it's 1. Pretty nice and easy. Okay, but what if it's a little bit different? Well, we just make it look like what we want to. We have limit as x approaches 0 of sine. I'm just going to rewrite the way this looks. I'm going to put x here, and I'm going to put the 6 over here. Okay, we want it to be sine of 7x over 7x, so we make it 7x. But if I divide by 7, I also have to multiply by 7. Now if we evaluate this part, that's 1. This part is 7/6, so that would be 7/6. It's not so bad. We're going to be doing arrangements similar to that for example 16. We can write this as x over x, or just 1, plus sine x over x. So if we have that, we have 1 plus 1, which is 2. Tangent of x, well, tangent is sine over cosine. Let me make a smaller pen for this one. So I can write this of sine over cosine. I can multiply the top and the bottom by cosine. So then I get x over sine of x times cosine of x. X over sine of x, as x approaches 0, that limit is 1. Cosine of 0 is 1. So this limit is 1. Okay, I won't have a lot of space for this one, but I'll try my best. We have limit as theta approaches 0. That's the same as 1 over cosine. See, I'm being a little clever here. And this in the bottom is the same as 1 over cosine. I'm going to write a little bit lower just so you can see it, but if you multiply the top and the bottom by cosine, you're going to get limit as theta approaches 0, cosine, or nope, you're not going to get cosine. You're going to get 1 minus cosine theta over theta, which fits our format, which makes this 0. All right, so how about this next one? We're going to break it up, make it look nice, make it look how we want it to look. So I have 4 sine of 5x over x times 1 over cosine of 2x. Well, I have the 4 there, that's fine. 1 over 2x, that part's fine. If only there was a 5 there, so I'm going to put 1 there. If I divide by 5, I also have to multiply by 5. So now in this case, we'll have 4 times 5, 20, times 1, times 1. We get 20. Okay, here, again, I'm going to write lower just to have a little bit more space. We have limit as x approaches 0. Tangent, I'm going to write that as sine of 3x over cosine, but I'm going to spread those out. And then I already have a sine of 4x in the bottom. Okay, in this case, we can use that idea from our last example where we had sine of, never mind, we'll go back to this. This is easier. We have sine of 3x, we could put that over 3x. Okay, I'm going to put the 3 up here. I'm going to put the x over here. Now I need that to be 4. So I'm going to put the 4 here. Okay, now we have 1 times 3/4 times 1, which gives us a limit of 3/4. All right, cotangent, if you don't like cotangent, you could change it to cosine over sine. And cosecant, that's 1 over sine. So if you spread out f, I'd like you to try that yourself, but if you spread that out, this one ends up being 25 over 11. This one, we could try to do it in class if you'd like. Same with this. But I would like you to do this one in your whisk. It may help to separate out the squared factors into two terms. Okay, there's a large box. You can memorize it if you want, or just break it down. It doesn't take that long. The last method that we have here is general cleverness. You tried everything else, so now you just have to kind of be clever. Okay, one way to be clever. There's a lot of things you could try to do with this, but we could start out by breaking this up into something like this. Ah, that looks familiar. So if we plug in 0, 0 times 1, 0. If we try direct substitution here, it doesn't work. So we got to think, what else could we do? Well, we rewrite our limit while we try to think of something. Well, I could factor that, I think, into x minus 5. This, I believe, factors into x minus 5 squared. So, square root of something squared, that would give us x minus 5. We could cancel that out. We get 3. And now we have part C. The best way, sometimes with trig functions, it's easiest just to turn everything into sine and cosine. I guess I should have a smaller pen for this one. So we have the limit as x approaches pi over 4. Pi over 4. We have 1 minus sine over cosine over sine minus cosine. And because I have an idea of where I'm going, I'm going to change this to cosine over cosine. That way I know I can combine them and start making it so it's not a complex fraction anymore. Alright, limit as x approaches pi over 4. In the top I'll have cosine minus sine. Cosine x minus sine of x over cosine of x. And the bottom, if I pull out a negative, let's be fancy, then I would have cosine x minus sine of x. These ends up canceling. Negative 1 over cosine. Okay, evaluate that at pi over 4. That's negative 1 over square root of 2 over 2, which would be negative 2 over root 2, or just negative root 2. I know I did that kind of quick. If you want to see it, just ask some questions. This one will be a big deal later, but you don't know how to do it that way, so we have to think of some other kind of way. Something that I want you to think about. This is a trig identity. Trig is really important. You need to remember this kind of stuff, and if you don't remember it, then you need to learn it, and you need to learn it quick. But if you want to expand this out, you can. Okay, I'll help you out with that part. We would have sine of x cosine of h plus sine of h cosine of x, and then we just have that minus sine of x all over h. I could factor out a sine of x. We might as well just finish this one. I would get cosine h minus 1 plus sine of h cosine of x all over h, and we are bringing down that limit. So now let's just rearrange this. I have sine of x times, hey, look at this. This looks pretty familiar. Plus, I have sine of h over h. So if we take the limit as h approaches 0 of this, sine of 0, 0. This, we know that as 0. Sine of h over h, 1. Cosine of 0, 1. or no, I mean cosine of x, because we're not plugging that in. Whoa, almost made a mistake there. We have sine of x because we're only plugging in 0 for h. Sine of x times 0, that part disappears, plus 1 times cosine of x. So our answer to this problem actually is cosine of x. So there's some kind of weird relationship when you set up a problem like this between sine and cosine, but that's okay. Trig identities, yay. So, yeah, you could try this one. This would be a good one to try. And maybe put in your whisk. Factoring is helpful if you know how to factor, and then you just evaluate. So this will tell me if you know your trig angles or not. Have a great day.